Whenever you make a decision in life, you could also make a mistake. You could be wrong. The same is true in hypothesis testing. When you make a decision about whether to reject the null hypothesis or not, you could make a mistake. We call those mistakes type 1 and type 2 errors. When you make a decision to reject a null hypothesis or accept a null hypothesis, which is really failing to reject the null, you could make a mistake. The null could be true, but you reject it. Or the null could be false, but you accept it. A type 1 error is rejecting a null hypothesis that is actually true, i.e., a false positive. A type 2 error is accepting a null hypothesis that's actually false, aka false negative. Now I could explain this with a 2x2 matrix in which we consider the true state of the world against the outcome from our sample and determine if we've made a correct decision or an error. But I find that at the beginning this is a little too complex, so I'd like to start with a more accessible example. To illustrate errors in decision making, let's consider the example of pregnancy testing. At any given time, most women in the world are not pregnant. So that is going to be our null hypothesis. If we select a random sample of women and administer pregnancy tests, there are 4 possibilities. Possibility number 1, the test correctly identifies a non-pregnant woman as not pregnant. You're not pregnant, the test says you're not pregnant, correct result. Possibility 2, the test correctly identifies a pregnant woman as being pregnant. You are pregnant, the test says that you're pregnant, correct result. Possibility 3. The test incorrectly identifies a non-pregnant woman as being pregnant. This is a false positive, or a type 1 error. Possibility 4. The test incorrectly identifies a pregnant woman as not pregnant. This is a false negative, or a type 2 error. So which of these errors is most serious? Well, if your test says that a woman is pregnant when she's not, this could cause a lot of unnecessary alarm. And a lot of your customers would tweet about this on Faceplant, and pretty soon people would quit buying your worthless lying pregnancy test, and maybe you get sued, and that's all bad. Well, on the other hand, if the pregnancy test tells a woman that she's not pregnant when in fact she is, she's more likely to just blame herself. Maybe she took the test too early. And now a week later, the second test is saying that she is pregnant after all, and none of the other twits on your Dig Dug account wall will have a conniption fit, and they'll all think you took the test too soon. So it's quite possible that the pregnancy test company would never find out about this type 2 error. So remember that, and we're going to come back to that in a minute. A type 1 error occurs when we say that there is a genuine effect in the population when in fact there is not. This false positive type 1 error is defined as rejecting a true null hypothesis. This means that you are saying that a treatment has an effect when it does not. Type 1 errors are serious because you are falsely reporting a treatment effect that does not exist. Research journals are greatly displeased with type 1 errors because it looks a lot like lying, and you can get yourself in a lot of trouble for lying in journals. It can affect your career. That is bad news. So to remember what is a type 1 error, think about Pinocchio. What happens when Pinocchio tells a lie? His nose grows. And his long nose reminds you of a number 1. So lying, saying that an effect exists when it does not, is a type 1 error. Peer review of submitted journal articles and retesting hypotheses, especially anomalous findings, are ways to guard against the publication of type 1 errors. The probability of making a type 1 error is the alpha level, typically p equals 0.05 or 5%. To decrease the chance of a type 1 error, you could change the alpha level from 0.05 to 0.01. However, decreasing alpha also increases the possibility of making a type 2 error. A type 2 error says that there is no effect in the population when, in reality, there is. A type 2 error is defined as failing to reject a null hypothesis that is false. This means you fail to detect an effect that actually exists. It's a false negative. But that's not a big deal, right? Wrong. Type 2 errors can be just as bad, if not worse, than type 1 errors. Type 2 errors can be especially unfortunate in medical testing. You are testing a cancer drug, and, unknown to you, this drug is actually effective on a very rare but deadly form of cancer. You test this drug on more common cancers, but because your sample size is too limited, you never pick up on the small number of patients who are cured by this drug. So the results are not statistically significant, and the drug never gets marketed, and then you or somebody that you love gets this rare form of cancer. The drug that could cure you is sitting right over there on the shelf, but you don't know it because you made a type 2 error. You missed it. So to remember a type 2 error, think of the old English parochial school dunce cap. This is the type of school that Pink Floyd sang about in Another Brick in the Wall Part 2. We don't need no education. We don't need no thought control. That one. If you're making a lot of errors, missing questions, getting answers wrong, you sat in the corner with your dunce cap. So think of the shape of the dunce cap. It's a cone, 2 lines, like a Roman numeral 2. You made a type 2 error, you big dummy. You missed the effect. So hopefully, Pinocchio and the dunce cap will help you remember type 1 and type 2 errors.